let's get started. So, you guys would have seen a lot of messages from me, which I'm calling as BYB, bring your buddy. So again, this is not a marketing campaign. Hi Srivatsam. This is not a marketing campaign. What we are trying to do is, if you guys have some of your friends also studying with you, and if they find me a qualified teacher, they can join the class. And the ultimate objective is that when you guys learn something from me in the class, you get to interact with your buddies and you exchange. Okay, this is what I learned, this is what I understood, this is what I found interesting, this is something that was boring, right? So there's a lot of collaboration that you can do among yourself, and that will help you refine or fine tune your learning experience. So that's the purpose. Obviously, I mean, having more students in the class creates more excitement for me also as a teacher, but at the same time, I'm not asking you to just bring anybody. I'm saying that bring your buddies with whom you exchange information, because that joint learning is a great thing. I mean, that helps in my mind. So that was the reason, but let me not talk too much about that. We will get going with what we want to learn today. We are still missing Sunarka, Vaibhav. Who else? Sunarka and Vaibhav, I think, yeah. But yeah, we'll get started. So today we just took a little diversion from the SAT syllabus. I just picked up one topic that came from one of you, which is on dealing with complex numbers. We know different types of numbers, but there's another flavor to that. That is what we're going to talk about. Tell me who all in this class already knows about what is a complex number, conceptually.
I don't know what complex numbers is.
Wonderful. That's an opportunity for me. Okay. Anybody else who knows or who doesn't know?
So it has I.
Yeah, Dhanushri, go ahead.
I said it has the value I.
Okay, that's a very mathematical answer to a simple question. We will come to I, but see what's up. You were saying something. No? Okay. See what's up. We'll join back again. Okay. So let's do a quick recap of what we know. Okay? I see what's up. See what's up? Can you hear me okay?
Yes, sir.
Okay. So you were trying to say something when I asked, do you know what is a complex number?
No, I just wanted to convey that I don't know.
Okay, that's fine. So whenever you guys say something that I don't know, that makes me happy. At least there's something that I can teach you guys. So let's everybody can see the board clearly, right? Okay. So we have seen different types of numbers so far, and let's do a quick recap of what we know. All these numbers that you see on number line, starting from 0, 1, 2, 3, 4, so on and so forth, and this side if you go minus 1, minus 2, minus 3, minus 4, so on and so forth. From number 1 till any extent you want to go, these are called natural numbers. Yeah?
Yeah.
You include, so this is natural numbers. You include 0 also into it, that becomes whole number. Yeah? I'm using the symbol, this one hash, denoting number. So 1, 2, 3, 4, as far as you can go, those are called natural numbers. Include 0 also into the list, that becomes a whole number. And you include negative numbers also, that becomes anybody?
Integers.
Integers. Yes. Yeah. So this is the basic understanding of numbers when we are dealing with numbers which are a complete number without any partial part to it. If you add something called, if I have 1, that is a natural number or whole number, whatever, or integer, whatever you want to call it. If I make or add a partial thing to it, like 1.2, what does it become? Decimals? Yeah?
Yeah. Yes.
So this becomes a decimal or a rational number. And when we say rational numbers, meaning any number that can be written in the form of a fraction. So 1.3 becomes this. Everybody knows this, right? I know I'm unnecessarily blabbering right now, but I'm just trying to make sure that we recollect everything that we know and then we add on the top of that. So this is called rational number. So when you say integers, you're talking about all the numbers, all positive, negative numbers, and 0 included is your complete list of integers. Similarly, when you say rational number, you're actually talking about all the numbers. Basically, everything that gets derived from integer, be it positive, be it negative, but has a fractional part to it, meaning something which can be converted into a fraction. Yeah. So this is integers, this is rational number. Up to this is clear, right? I mean, there is nothing new and nothing confusing so far. Yeah. Okay. Now let's add more fun to it. And stop me, guys, wherever you think I'm not making sense. Now, if I have a 9, I can say this is equals to 3 square. Agreed?
Yes.
If I say square root of 9, that will be equal to square root of this. Agreed?
Yes, sir.
And that will be equal to 3. Now there is one more part to it that you want to quickly do a recap. See, when I say square root of something, that means this. Or you can say this to the power 1 by 2. Yeah?
Yes, sir.
Dhanushri is saying yes, sir. Everybody else is keeping quiet. I'm assuming that means a yes. Yeah?
Yes, sir.
Okay. Alright. Now, this helps us relate it with the exponent's rule. X to the power A to the power B is equal to x to the power A into B. Yeah? And that is how it becomes 3. So, square of 3, square root of 3 square gives you a 3. So there are different ways of relating to things. Now, if I say 27 cube root, same way I can say that means 27 I can write as 3 cube, which is equal to the rational exponent that we have learned in the past, this to the power 1 by 3. If I have something to the power 4th root, let's say 64 to the power 4th root, that means 64 to the power 1 by 4. Yeah. So here 27 I can write as 3 cube and cube root of that. So 3 cube root converts to 1 by 3. So this becomes x to the power A to the power B. That means 3 to the power 3 into 1 by 3. A into B. And that is how it became 3. Now, so far this is easy peasy, right? Whatever we knew, we had just looked at it. Now, let's look at one more concept. If I have minus 2 multiplied by minus 2, that makes it minus into minus is plus, and 2 into 2 becomes 2 square. This part is fine, right? Or I can, if I have 2 square, I can say this as 2 into 2, or I can say this as minus 2 into minus 2. Both are same. Everybody with me so far, right?
Yes, sir.
Okay. Now, that means if I have, instead of 2 square, if I just write this as 4, which we know as this is 2 square, if I have a positive number, and if I have to find out the square root of 4, I have two options. So this will be like 2 square root of this. So that will be plus 2 or minus 2. I have two options now. So basically, when I have a positive number, I can get a square root of that, which could be positive or negative. Up to that is fine. Life becomes more interesting when somebody says, find out the square root of minus 8. Or let's pick an easy number, 16. You cannot say, so this minus 16 would be probably minus 4 into plus 4. This is what is resulting to minus 16. Now if you take a square root of this, you are saying minus 4 square. Will this give you a plus 4 or minus 4? Will this give you a plus 4 or minus 4? Square root of 4 square, minus 4 square? Yes or no?
Yes.
It will not. It will not. When you have a negative number, see, when you are doing a square root of something, that means you have to break it down into two equal things, right? Like when we have to do a square root of 16, we said, okay, fine, this is 4 square. So I have two similar things. So when I do a square root, I can knock off 1 and I get 1. Now, if you have minus 4 into minus 4 and then you do a square root of that, you get a minus 4. This is fine. The problem is you have 1 plus 4 and 1 minus 4. You cannot get a square root of that as minus 1. And this is where it becomes a number that doesn't hold technically right. And we call it a number that doesn't exist or an imaginary number. It's an imaginary number. A square root of a negative number is not technically a realistic number, and that's why it is called an imaginary number. A moment of silence. Yeah?
I understand, sir.
Yeah. So when you are dealing with a square root of a negative number, which is technically not a valid number mathematically. Come on. So when you are dealing with a square root of a negative number, which is technically not a feasible number, that's what is called an imaginary number. Yeah? And that is why you deal with something which is the acronym for imaginary, and you deal with this thing called I. So, a quick recap of what we are seeing. So, when you are dealing with a square root of a number, any number, let's say you have square root of, find out the square root of 64. 8 is the 64, that is 8 square. So, you should find square root of 64, that is square root of 8 square, and that gives you an 8. Or you can say, I can write I can write 64 as 8 into 8, meaning plus 8 into plus 8, or you can also write this as minus 8 into minus 8. Yep. So when you say square root of 64, that means either square root of this or square root of minus 8 into minus 8. So that is why when you say I am doing a square root of 64, you will say here the value will be 8, here your value will be minus 8. So doing a square root of 64 gives you either a plus 8 or a minus 8. Yeah. So this is all real numbers. Life becomes more interesting, as I was saying. If you have to do a square root of minus 64, here the best way you can break it down would be minus 8 into plus 8. And you will not get a definitive answer here. You will get 8 because it's plus into minus, I will say plus into minus 1 inside square root, and then 8 comes out because you have 8 square. So you have 8 into square root of minus 1. So basically what I'm trying to say here is square root of a negative number is unrealistic. It doesn't give you a definitive answer. So mathematician said, yeah, fine. I mean, it's non-definitive and we cannot find it out that easy, but we cannot avoid them either. These are the villains of the movie whom you don't like, but you cannot avoid them. Yeah. So they are not realistic, and that's why they are called imaginary numbers. The square root of any negative number is called imaginary number. Imaginary number. Okay? Because you cannot find the square root of a negative number. Everybody with me so far? Yeah, here.
Wait, sir, can you repeat that? Can you repeat the last sentence?
So I'm saying you cannot find out a square root of a negative number. How do you get a negative? Plus into minus gives a minus. Minus into plus gives a minus. Minus into minus gives a plus. Plus into plus gives a plus. So this is what you would have seen before. Equals plus. Minus into plus gives minus. Plus into minus gives minus. And plus into plus gives a plus. So if you have a positive number, then you have both the signs as positive or both the signs as negative. That is when you break it down, you get a definitive answer or a realistic answer. When you are dealing with something like this, you will not get a definitive answer. The best you can do is you will say, okay, fine, minus 9 I can write as minus 1 into 9, and I know minus 1 and 9 is 3 square. So I will just take this guy out, 3 comes out and minus 1 remains inside the bracket. Yeah, but you did not get a definitive answer because finding out the square root of this can lead to this or this, and both will not break it down equally. So that is why this is called imaginary number. When you are dealing with a complex number, keep the complex number aside. When you are dealing with a square root of a negative number, you will not get a definitive answer. That's an unrealistic answer, and that's why it's called imaginary number. So if you deal with any number with a negative sign, and you have to find out the square root of that, that will be an imaginary number. That will be your first response. I'm just saying square root of a negative number, okay? I did not say cube root or anything else, okay? Are you guys with me so far? Did that explain?
Yes, sir.
Okay. Yes, here, go ahead. Saying something.
And I clicked on a mistake, sorry.
That's okay. Alright, so By now, I have bored you guys enough with the definition of imaginary number. Nobody should have any doubt with respect to why something is an imaginary number, right? Neil, Sarah, Srivatsav, Arya, Dhanushree, everybody's okay?
Yes, sir.
Okay. Now, so I promised you guys that today we'll talk about complex numbers, and I have not even touched what is a complex number, right? So a complex number is a number which has real and imaginary number both as a part of it. Meaning, now I will not call this as an imaginary number. I'm very lazy. I know that if there is a minus in the square root, this is going to be an imaginary number. What we do is, we all become lazy and say we'll call it I. So that's what Dhanushree was saying, that a complex number is a number which, or imaginary number is something that has an I. Right, Dhanushree?
Yes, sir.
Now we all know what is this I. So whenever we are dealing with anything which is imaginary in nature, we'll use the acronym I for that. So when I say complex number, what I mean by that is, complex number is a number which has real and imaginary number both as part of it. So let's say A is a real number and I is my imaginary number. Okay? This is the form of a complex number. So when I say complex number, it's a number which has real number and imaginary part also into it. Is everybody with me so far?
Yes, sir.
Now, A and B are constants, these are numbers. So if you see something like 3 plus 2i, that is your complex number. Now, for the sake of simplicity, here, this I has a very definite definition, okay? Meaning, if I have an imaginary number, right, let's say minus 64, this, I can always write this as minus 1 into 64 square root, or minus 1 into 8 square root, or I can take this guy out, 8 into minus 1 square root. So Dhanushree, can you confirm me if this minus 1 square root is called I or it's a generic term? It's minus 1 square root is called I, correct?
Yeah, minus 1 square root is I.
Yeah. So what we have tried, I mean, what the, not me or any of you, what the mathematician did was that if you have an imaginary number, you can take minus 1 out and rest all you can find the square root for, because our problem was with the negative sign. So any number, minus 24 square root, okay, fine, that is equivalent to minus 1 into 24 square root. We can deal with this number separately and deal with this separately. That's why they segregated that, saying, okay, fine, square root of 24 into square root of minus 1. And that will hold true with any number, right? Any imaginary number that you deal with. Minus 81 square root, simple, minus 1 out and 81, because we know how to find out the square root of this guy. Our problem is with this one. So let's outcast the problem. That's what they are trying to do. Yeah? So that is why this minus 1 square root is been given that term, imaginary, because this is the most painful component of the problem that we are trying to solve. If you take this guy out, problem is taken care. Yeah. So whenever you come across the term I, always remember that as an imaginary number, and I here in this case represents this as minus 1, square root of minus 1. Okay. So when you deal with this, with, let's say, when I said there is a complex number is nothing but real number plus I. Because it's, again, as I said, right, I'm lazy. Everybody is trying to be lazy when it comes to putting effort for solving things, right? I mean, if it takes you 10 steps for doing something versus if you know the trick for doing that in 8 steps, obviously you lean on doing that in 8 steps, right? To save the effort so that you can use that time saved for doing other sums. So same way here, instead of writing this much, right? See, just writing this, I'm saving some time. We don't have to write that much. So this has been defined as the I stands for the imaginary component of a number, or you can call it imaginary number, whatever. But the value of I is minus square root of -1. Up to this, everybody with me?
Yes, sir.
Yes, sir.
Neil, Sarah, everybody?
Yes, sir.
Okay, wonderful. Alright, so now all that I did was just to misguide you. It sounds its name is complex number, but actually it's not that complex. Now you look at this as C equal to A plus BI. Now look at this. This is more like, again, A and B are constant, so you'll probably come across a complex number like C equals 3 plus 2I. And you know that this is trying to give you a number. This is just a number, which means 3 plus 2 into square root of -1, right? If you're dealing with this number like this, like everybody in the world knows pi equals 22/7, right? Same way, whenever you see pi, it doesn't bother you because it has a fixed finite value. Same way, when you see that I, think of that as a finite thing, which is equal to square root of -1. Now, you can deal with complex numbers in the way you deal with any equation, anything, okay? But before I go further, up to this much clear, you guys, right? Yeah?
Yes, sir.
Dhanushri, Srivatsav, Sarah, everybody?
Yes, sir.
Heel, Shravya?
Yes, sir.
Whatever. Now, I said this is a complex number A plus BI. And excuse me for my pronunciation, okay? There is a term called conjugate. Conjugate. Am I pronouncing it right, Dhanushri?
Yes, sir.
Okay. So conjugate is nothing but, it's like when you talk about something like a complementary thing, right? I mean, you buy a pair of shoes, you get socks free. Right? It's a complementary thing. Something that augments or relates to that. So here complementary and conjugate has no relationship. I was just trying to find something that is closer to it. So if I have a complex number, this will be in this form. This is called the standard form of a conjugate for a complex number. It's a standard form, A plus BI. And A and B are two numbers, real numbers, and I, the whole world knows now, right? So when you say conjugate is something, let's say I put a J or G, whatever you want to call it. It will be this one. So if I have this A plus BI as my complex number, conjugate of that will be this. Or if this is my complex number, the conjugate of that will be this one. Basically, your sign is inversing for the imaginary part of the number. Okay? This is my imaginary part, this is my real part, right? So the sign is just the inverse of the actual number for which you are trying to find the conjugate. Let's say if I say my complex number is 3 plus 2i. What is the conjugate of that? 3 minus 2i. If my complex number is 16 plus or 16 minus 6i, what is the conjugate for that? 6i. Just the sign reverses. Is that part clear?
Yes, sir.
Now, take all the worries out of your mind that you are dealing with something so different. It's nothing different. It's just another problem or the sum that you are dealing with. Let's say if somebody says 3 plus 2i into 6 minus 4i. Multiply these two numbers. You'll multiply these two like you deal with regular algebraic expressions. Same way. You'll multiply this with this, multiply this with this, this with this, this with this. What will that become? 3 times 6, 18. 3 times 4i minus 12i. 2i into 6 becomes 12i. 2 into 4i will be minus 8i squared. Oops. I squared. Yeah. Now this is minus 12i and this is plus 12i. You did tic-tac-toe. This is 18 minus 8 into I squared. What is I? Minus 1. So this 18 minus 8 into minus 1. I'm replacing this with I with a minus 1, square root of minus 1. Yeah? Then this becomes 18 minus 8 into, what will be the value of this? Okay, on the screen, anybody? What is the value of this part? Minus 1 square root times square. I mean minus 1 square. Minus 1 square root, square of that. What will the value of this one? Anybody?
Could you please repeat that? I couldn't.
No. Now I'm saying I'm just trying to multiply these two numbers, okay? I have two complex numbers, 3 plus 2i and 6 minus 4i, and I've been asked to multiply these two numbers. I'll multiply it like a regular algebraic expressions, right? So this one I'll multiply with this guy, 3 times 6, 18, then multiply this guy with this guy. So 3 times 4 minus 12i, and then repeat the same thing, 2 into 6, 2i into 6 is 12i, and this times this will be equal to plus into minus will be minus, 2 times 4 is 8, I times I is I squared. Yeah. Now I am saying okay, 18, these two, what 12i plus and minus gets knocked off, so it becomes 18 minus 8 into I squared, or 18 minus 8 into I squared. The whole world knows I is minus 1, square root, square of that. So I'm asking you guys, what will the value of this? Square root 1 square of that. What is the value of that? How much? That is correct. So I'm just waiting to get some response from the screen. Yep.
I squared?
Say that again.
I squared?
It is I squared, but we know that I is equal to minus 1 square root. Yeah. So I'm trying to ask you guys, tell me what is the value of this one. See, if I have square root of 2, oops, my pens are drying fast today. Okay. If I have, watch it carefully, okay? Square root of 2, square of that. What will the value of this?
Oh, is it just -1 then?
Yep, you have spot on. Yeah. That's the answer I got. Everybody who was quiet. If I have square root of 2, square of that will be equal to 2. If I have a cube root of, let's say 4 to the power 3, that will be equal to 4, right? This and this negates. Yeah? Or you can look at it this way, right? Like the way you were trying to solve exponents. If I have a square root to the power 2, what does it mean? It means a square root I can write as 1 power 1 by 2 to the power 2. Yeah. Now this is an exponent, x to the power a in bracket to the power b. That becomes x to the power a multiplied by b. Yeah? If you remember the exponent formula, x to the power a to the power b equals x to the power a into b. Yeah?
Yes, sir.
Same thing I am relating here. So if I have a square root and I have to do a square of that, square root square of that negates it. Yeah? So same way here. Everybody is able to follow me, right?
Yes, sir.
Yes, sir.
Yeah. Okay. So square root of minus 1 and then square of that gives me, I don't know how many pens I'll finish today. 3 pens I've already thrown. Let's look at the fourth one. 18 minus 1 square root square of that. Anything which is in square root and we are doing a square of that just knocks off the square root. So 18 minus this becomes minus 1. Yeah? Oh, yeah. Yeah, we had an 8 here. Yeah? So this becomes 18 minus 8 into minus 1. That becomes plus 8. So the answer is 26. Now, I was not trying to rush for getting this answer. What I was trying to tell you guys was, when you look at any complex number like this, think of this like an expression. Like how you will deal with an expression. How you will deal with, it's like x and y form, basically, right? Like x and y are variables, unknown. Think of I as an unknown, which is eventually known as square root of minus 1. Think of that like a regular variable and then you can deal with that. So let me do a quick acid test to see, not to see what you have learned, rather to see what I have explained, okay? So if I tell you guys 4 minus 2i is a complex number, multiply this with other complex number 3 minus 6i. Let's see if you guys can solve this quickly. At least that will give me a clue whether you all have understood this or not. So the question is 4 plus 2i multiplied by 3 minus 6i. If you could just solve it quickly before we move on. Solve and tell me how much it is and what did you do. And I would want everybody to try this so that Prince, would you want me to turn on the fan? Yeah, fine. Okay. Yeah, sure. Yeah. See, this works. Everybody is trying, right?
Yes, sir.
Okay. Let's see. Okay. So start with the question first because I was trying to find there. So 4 plus 2i into 3 minus 6i. You write it from there and then you go step by step. So that way it becomes like a story. Anybody is ready?
I'm ready, sir.
Yes.
I'm ready.
Okay. Okay. So how much is the answer, Arya?
I'm not sure if I did it correctly, but I got 12 minus 30i.
12 minus
That's
30i.
what I got too.
12 minus 30i. Is that your answer, Arya?
Yes, sir.
Okay. How about you, Dhanushi? Same number? 12 minus 30i?
Yes, sir. I got 12 minus 30i too. But I think it could be simplified because of a plus bi.
A plus.
Oh, well, never mind.
It's already simplified. So this is your A, this is your B, and this is your I. Yeah. Sarah, Neil, were you able to?
I got confused.
You are confused. Okay, that's okay. That's fine. We'll break it down. So that's why I did not keep a lot of things in the agenda today. Okay, yeah, here.
Sir, I didn't got 12 minus 30. I got 24 minus 18.
Okay, that's another answer.
Yeah, like I opened the brackets, expanded it, and
24 minus 30i, that's what you said?
yeah. No, 18.
89. Okay. So, like I keep telling you guys, I don't trust anybody. Not because I don't trust you guys, I certainly do. But when it comes to math, I'm just writing it down like an option. Because I will do it myself to be clear. So, Neil said he got confused. That's fine. Sarah, how about you, beta?
I'm still
Working? Okay, how about you, say what's up?
I'm confused, sir.
Okay, that's good. So, see,
I have to go right now.
okay, yeah.
Can I do the homework and stuff and come back tomorrow?
Sure. So Shravya, the only thing would be, whenever you miss a class, the best way for you to do a recap is watch the classes video. I mean, just omit the part where I'm blabbering. That part you can take out, and only the key content part where I'm explaining something. So that way, you can save time and make sure that you're not missing something. Okay.
Okay,
Yeah.
cool. Thank you.
Yeah.
Bye.
All right. Bye bye. Okay. So I think let's do it. But before I do it, so for Neil, Sarah, you want to take one more minute to finish it before I start, or I can
You can
start?
start.
Okay. Now, a very simple thing. Before we try doing this one, this has nothing fancy about it. Okay. Now, let's say if I have two expressions like this, x plus 2 multiply that by x plus 3. Okay. Our job is to break the brackets, right? That's what you would have learned in BODMAS or PEMDAS or whatever you call it, right? Your first job is to break the brackets or do the operation with the bracket. Now, inside the bracket you have x plus 2 and here you have x plus 3. You cannot do anything. X is a different thing, 2 is a different thing. So now you have to basically get rid of the bracket first, so that you can say that I'm done with the bracket. Now, here, how you break it down? You pick the first number, multiply with this, pick the number, multiply with the second one. Similarly, you pick the second one, multiply with this, but pick the second number, multiply with this. That is how you break the bracket. Right, Neil? Are you aware of this part?
Yeah.
Okay. Now, let's use the same thing. There's nothing new that we are doing, okay? As I said, complex number was only, I started talking about this was, the only reason was to get you guys confused. There's nothing complex about it. Just that the imaginary part, minus 1 square root, this has been given a name I, okay? That's it. There's nothing more than that. Now, what we have here is They are two complex numbers. One is 4 plus 2i, second is 3 minus 6i. Same thing, 4 and 2i, these are two different creatures. You cannot put them together. These are two different creatures, you cannot put them together. So there is nothing that you can do inside the bracket. So the next option that you have is break the bracket. Same way, pick the number, multiply with this, Pick the second number, multiply with this, multiply with this. That is how you go about it. So pick the first number 4, multiply with both the numbers. 4 times 3 gives you a 12. Done. This one is done. Now 4 times 6i. Here you have nothing but plus 4 and you have minus 6i. So 4 into 6 gives you 24. And here plus and minus gives you minus. So minus 24i. And then this number is done. Now you pick the second one. 2i. So this is a plus, so we'll write a plus. Plus 2i into 3. So 2 into 3 gives you a 6. 2i into 3 is a 6i. And then you multiply this with this. So plus into minus gives you a minus. Minus, first you multiply the signs. You get a minus. Now you multiply the numbers. 2 times 6 is 12. I into I gives you I square. Yep. So everybody, regardless of what number you got, just check whatever I am doing here, is that in line with what you did. And you would have noticed, if you have attended few classes by now, you would have noticed that I don't do mind maths. I do it on the board. And I would want you guys to do it the same way, because this helps you make sure that you can review what you have done. Okay? This is like telling a story. You skip one character of the story, the whole story goes for a toss. Yeah? So don't jump steps. Okay? Now here you have 24i and you have 6i. So minus 24i and 6i. This gives you 12, remains 12. Minus 24i plus 6i gives you minus 18i. This much of loan, this much of earning. Now you still have a loan of 18i. Minus 12 into I squared. Now I, everybody knows, is minus 1. Square of I will be square of minus 1, square root. That is nothing but minus 1. Yeah. So 12 into I squared will become 12 minus 18i minus 12 into minus 1. And I am purposefully keeping this inside the bracket, otherwise it might get confusing. You will say minus 12 into minus 1 and this becomes a, this is I square gives you a minus 1. Now you look at your calculation. What did it become? 12 minus 18i, and this minus into minus becomes plus 12. What did it become? 24 minus 18i. Now you can check if I made a mistake or you missed something. Whoever did not get this number, probably there is something that you overlooked. Yeah?
Yes, sir.
So now question back to Neil, Sarah, Dhanushree, Arya and Hir. Did you guys understand what did I do?
Yes, sir.
Yes, sir.
And I would not claim that I have done anything fancy. This is basic math that you all know. Only thing that we have gotten introduced today is I. Yeah? Which is nothing but square root of minus 1. And by now we all know square root of minus 1 is called imaginary number because it's imaginary. Square root of a negative number is technically not possible. Yeah?
Yes.
Everybody clear?
Yes, sir.
Now let me give you guys some more fun stuff. Take one thing, keep one thing in mind. Complex number is not complex. As simple as that. It's a simple normal expression where instead of x or y that you have been dealing with so far, you're dealing with I. That's it. That is how I would want you guys to look at it. Some terms that you will come across, obviously imaginary as I or conjugate and all, right? That we had not heard before. But then when it comes to dealing with them, it's simple algebra that we all know. Now let's take an example. 3 minus 4i multiplied by 3 plus 4i, let's say. Now how do you say it? a minus b into a plus b. What will it become? A plus b into a minus b into a plus b. It becomes a squared minus b squared. So 3 squared minus 4i squared. That's what it becomes. Yeah. So you can apply all the algebra rules or the calculation or computation techniques that you already know, and just deal with I as another variable that you have been dealing with so far. It becomes a square minus b square, that is 3 square is 9 minus this 4i square becomes 4 into 4 16 I square. Yeah. Now you know 9 minus 16 I square. I square is what? Minus 1. 16 into minus 1 became 25. So what was looking complicated here usually became a simple number, just because you knew what exactly is I. Yeah. So if I trick you guys and say 16 minus, let's say, 12i plus I square, okay, divided by 3i. Can you guys try solving it? Applying all your algebra knowledge. Or let me solve one and then we'll come to this. Now this is my one expression, 16 minus 12i minus plus I squared. Now when we are dealing, this is nothing but a quadratic equation, right? I have some square here, I have some value which I can, 16 I can write as 4 square minus 12i. What did I do?
Plus -1.
Yeah. Okay. Okay, what is that?
You could change the I squared to a -1 form.
No, sorry.
Since it's an I squared, it's -1, so
That will be one way. I'm saying that let's do something different. Okay? So maybe don't try solving it. I'm saying, I mean, what you said is not wrong. You will convert this I square into -1 and then this becomes -1 9, so it becomes 16 minus, okay, so there are two ways of solving it. So let's do the simple way first, like what Pandit is saying. So I have to do 16 minus 12i plus 9i square. Now I square, as soon as you see I square, that means -1 square root square. So I square will always be -1, as simple as that. Yep. So what Pandit is saying is, you'll say okay, 16 minus 12i, 12i remains 12i, plus 9 into -1. So this becomes 16, whatever we have in the denominator, let it remain like this. So 16 plus, this becomes -9. So 16 minus 9 minus 12i divided by 4 minus 3i. So 16 minus 9 is 7 minus 12i divided by 4 minus 3i. And this is where you will be stuck. There is nothing more you can do. Yeah? Are you guys with me so far?
Yes, sir.
Okay. Now let's deal with this like the way we deal with quadratic equation. Okay. I'm saying I see this as 16 minus 12i minus 9i square. This 16 I can write as 4 square. 4 square minus 12i plus 9i square divided by 4 minus 3i. Okay. Now this is a square, b square, and whenever I see a quadratic equation like this, we'll always try relating that with
A plus B whole square equals A square plus 2AB plus B square. A minus B whole square is equals to A square minus 2AB plus B square. A square minus B square equals A plus B into A minus B.
There are the three basic formulas or rules that we know. We'll try relating that with one of these. So since I have a minus, this one doesn't look like a form. Since I have only two, here I have three terms. This is not looking like a form. I cannot break it down. So I have A square, B square. I don't have here this thing. So this one doesn't qualify. So maybe this could be the option. Can I think of this in this A minus B form? Is it in this form? This is A square, B square. What is A square? A here, 4 is A, and what is B here? 9I square will be 3I will be equal to B. If it's in this form, then I can say this 2AB minus 2AB minus 2 into A into B. Okay. So when I was framing the question, I missed one calculation. I'm just trying to put this. Now, if it is in this form, then I see, okay, fine. If A is 4, B is minus 3I, then this is by this form. So this becomes 4 square minus 24I plus 9I square by 4 minus 3I. This is nothing but this is by 4 minus 3I square. A minus B whole square divided by 4 minus 3I. Okay. So then A square by A, just here A, that is 4 minus 3I. Now coming back to the way we were solving when Pranit was giving this, right? So if this was 24I, then that would have been a different story. This would have been 7. Okay, no. That would have not given that answer still. We still have to go this route. So here what I'm trying to say is, if you have to deal with the complex numbers, you always have to go back to your basic understanding of the quadratic equation or any algebraic expression that you deal with, and deal with that in the same way like you deal with x and y. I is just another variable for you to deal with. Okay. So when you look at a complex number, don't start worrying about that being a very unique, very difficult thing. Rather, you should look at so we are just trying to conclude the class for the senior kids. Just 2 more minutes, okay? Then we'll start with the younger ones. So yeah. So whenever you deal with any complex number, whenever you come across this kind of an expression, hey Riti, 2 more minutes, we'll wrap up this class, okay? You can stay, just listen to all the conversation that you don't understand, but still, just hang in there. So that is the way to deal with complex numbers. Any questions so far?
No, sir.
Yeah.
No, sir.
So find out few practice sums. Dhanushri, you would have few more sums in the practice test, right? Just look at those and apply this concept. Take out that apprehension from your mind that complex number is something different, and then try solving it like you will deal with x and y. Okay? And then see if you are getting stuck anywhere. Alright? Yep. So here, Srivatsav, Sara, Arya, Neil, and Dhanushri. For you guys, I would want you guys to find out some sample sums, either on Khan Academy or just on Google. Okay, search for sample problems to solve using complex numbers. Okay, if you don't have an exercise book with you, sit down. Don't keep roaming around. Okay, so try solving few sums, and if you get stuck anywhere, then you know whom to charge. Yep.
Yes, sir.
So everybody, make sure that you all have my WhatsApp number on your phone, and whenever you are trying to solve something and you get stuck, send me a WhatsApp message saying, oh, this is the sum that I am not able to solve. Okay, and then I will solve it for you and send it back to you. Yeah.
Yes, sir.
All right. Thank you for your time and hope we learned something.
Bye.
Thank
Bye-bye.
you so much, sir.
Yeah, all right. Bye-bye. Bye-bye. Bye-bye.
Bye.
Bye-bye.
Thank you. Nice.
Yeah. So we have Aditi and we have Shranvi. We'll just wait for 2 more minutes for everybody else and then we'll